All right, today we're going to look at 5.3 from the Methods textbook online. So you would have already had it downloaded, but here it is up the top that says Chapter 5 questions, and that's where you get the textbook from. Work completion here tells you which questions you need to do. So today you'll be doing from 5.3 these questions here. So the highlighted purple is Calc Active, so that'll save you a heap of time. Make sure you pay attention to that. And the textbook looks like this: differentiation of exponential functions. So the first thing up the top there, we've actually gone through those last week, but what I'm going to do is start off by just helping you revise a little bit on that, because you may not have remembered everything. So you might remember the rule to find dy dx. So I've written it out here already, save a bit of time, so just pause it if you need to. To find the derivative of this, the first bit's easy, it's just a polynomial. So 2 times minus 3 is minus 6x to the minus 4. Take one off. Then to get this one, we find the derivative of this, which is 6x, e to the 3x squared. That just stays the same. So the derivative of that power comes at the front and keep the rest the same. If you get one like this, you have to separate it out and make it 3e to the 2x over 2e to the 3x minus e to the minus x over 2e to the 3x plus 4 over. Okay, you might do a shortcut with that, but then you can simplify this and make it 3 on 2. 2x take 3x is e to the minus x minus, this will be a half, because that's just like a 1 on 2. Then we've got minus x take away 3x. And this will be 4 over 2, which is just 2 e to the minus 3x. So now all our exponentials have been up on that numerator now, and it's a bit easier to do. So the derivative of this is minus 1, so it's minus 3 on 2 e to the minus x. The derivative of minus 4x is minus 4, so this will become plus half of 4 to e to the minus 4x. And then this will become minus 6e to the minus 3x. Sometimes you'll be asked to find the gradient then at a given point. So let's look at this question 1 here. The gradient when x is 0 would be, this one wouldn't actually work. It'd actually be undefined. I didn't plan that too well, did I? Because this will be minus 6 over x to the 4, so it'll be minus 6 over 0, so the whole thing is undefined. We can't find a derivative at x equals 0. And then come to think about it, if we did a graph of this, we know that there would be an asymptote at x equals 0. All right, what about this one? Find the gradient when x is 0. This would be e to the 0, which is 1, e to the 0, 2, and then 6. So it's minus 1, I'd probably go minus 3 on 2 plus, this would be minus 4. So that's like minus 5.5, because we've got minus 4 and then take away 1.5. So remember, we could do that on our calculator. This will be pain for you, watch me do this, but fast forward through it if it disturbs you too much. I'm going to put in menu, calculus derivative, d dx of, and I'll do the first one, 2x to the minus 3 minus e, and we have to use that function e, to the 3x squared. The derivative of that is what we got, and then we can say, what is the value of that given that x is 0? And hopefully it'll say minus infinity, we said undefined, same deal. And then the next one we can check that. I'm not going to do that because we'll get a bit bored, but you can check that yourself. All right, let's look on the next bit. And again, just a little bit of revision. Remembering how to find the tangent and the normal using CAS, because most of the ones you do are calculator active. So it's, look, I always do a define, just because when you're in year 12, you'll find that that works really well. So this is what I do, and it might be a bit annoying, do it your own way, but let's have a look. Menu, actions define, f of x is function e to the minus 4x. What's that actually a function, is it? It's a value, plus 3. And then I can go menu, calculus, tangent line, 9. F of x at x equals 1. It's a bit tricky, isn't it? Anyway, we just write it down. I'm going to write minus 4 over e to the 4 x plus 3 e to the 4 plus 5. So I'm just going to transpose it positive powers. It doesn't matter. Any of those answers would be fine. And if we wanted to find the normal, I can do the same thing, but it'll be menu for a. Again, it's f of x. I don't have to worry about typing that in at x equals 1. And same thing, we can just write that down. And I am going to write it down, and you can write it down too. So that's as exact values. You will do ones like that. And obviously any form is fine. So you will do a few of those, hopefully. That will be fine. Let's have a look at this one. So we start to get sort of some mixed problems where you have to apply your knowledge. So we haven't specifically done an example like this, but knowing what you know, you should be able to do it. So first one here, f dashed x. Derivative, this is just e to the x. Derivative of e to the x is e to the x. So it's just going to be a e to the x minus 3b e to the minus 3x, because I put the minus 3 out the front. And this stays the same. That's weird. Show that f dashed x equals 0 when e to the 4x equals that. All right. So again, we haven't seen it before. Let's have a look. F dashed x equals 0. 0 equals a e to the x minus 3b minus 3x. So I think I'll try and get an e to the 4x on its own. I don't know. I'm just going to take a guess and take this over here, because that seems like a pretty sensible thing to do. And now I can see, if I divide by this, I'll get the x plus 3x, because this will become positive when it comes up. And then I can just do 3b over a equals e to the 4x. So you don't always know exactly what to do, but just keep following the bit of a vibe and you'll sort of just figure it out. And calculator wouldn't help us with that. This one, f dashed of 1. So I'm going to simplify this and make it e to the 2x plus 2e to the minus x. That's just doing 3x over x, 2x, and 2 over e to the x. Then I can find the derivative, which is 2e to the 2x minus 2e to the minus x. So at 1, it would be 2e squared minus 2e to the minus 1. And that'll do. If you want to, you could write 2e squared minus 2 over e. Doesn't matter. And this, I just thought I'd show you this because the notation's a bit weird. What this means is find x such that the derivative is 0. So it's basically saying, where is the derivative 0? Okay, where is 2e to the 2x minus 2e to the minus x equal to 0? And you just solve it. So I'd go 2e to the 2x equals 2e to the minus x. They'd cancel out. I might divide this under and make it e to the 2x divided by e to the minus x is 1. So that means e to the 3x is equal to 1. And I don't know if you've seen logs, but you would actually say from here, that means the natural log of 1 equals 3x. So x equals 1/3 natural log of 1. Haven't really taught you that. The log of 1 is 0, so that just means x equals 0. So that'll sort itself out. Now, I do want you to know that when you go into Canvas, not only have you got the chapter 5 questions, the ones you meant to do, and then there's some solutions for 5.3. So these are handwritten ones that I've done. So if you're stuck, they will often give you a hand. If not, I'll catch you in Zoom later on today at 10:15, And any you specifically need to go through, you can just tell me. But I'll be on the chat and on email. So if you need me, let me know. Otherwise, I'll see you on the Zoom.